Right now, beneath your feet, there is an ocean. Not a lake, not an underground river, an ocean, possibly bigger than every ocean on the surface of our planet combined. You've never seen it. No submarine has ever reached it. And until a few years ago, most scientists weren't even sure it existed. Today, we're going 660 kilometers straight down to find it. When you picture Earth's oceans, you probably picture the Pacific, the Atlantic, the Indian Ocean, blue water stretching to the horizon. But here's the problem. Everything below the crust is solid rock, squeezed under pressure so intense it would crush a submarine like a soda can. So how could there possibly be an ocean down there?
That's exactly the question that sent scientists on a 10-year hunt for proof. In 2014, a team of researchers was studying a diamond that had been violently pushed up from deep inside the Earth by a volcanic eruption. Diamonds like this are valuable to scientists for one reason. They act like a time capsule, carrying pieces of the deep Earth to the surface completely unchanged. Inside this particular diamond, they found something no one expected, a mineral called ringwoodite, and trapped inside that mineral's crystal structure was water. This was the first direct physical proof that Earth's mantle could hold water, published in the journal Nature, and it sent shockwaves through the geology community. So what exactly is ringwoodite?
It's a form of the mineral olivine that only forms under extreme heat and pressure, the kind of conditions found roughly 410 to 660 kilometers below the surface, in a region called the transition zone. Here's the part that surprises most people. This isn't liquid water sitting in an underground cave. There's no wave, no current, no surface you could dive into.
Instead, water exists as hydroxide ions, locked directly into the crystal's molecular structure, like a sponge that never lets go of what it soaks up, only at a microscopic mineral level, spread across thousands of kilometers of rock. Now for the number that made headlines around the world. Based on ringwoodite samples and seismic data, some researchers estimate the transition zone could hold as much water as all of Earth's surface oceans combined, maybe even 3 times more. That would make it, by volume, the single largest reservoir of water on the entire planet. And we didn't even know it existed until recently.
But scientists are careful here. This isn't confirmed with certainty. Estimates vary widely, and researchers are still working out exactly how much water the mantle can actually hold. Here's where it gets stranger. Scientists didn't just find this water by luck. They found it because it was already showing up in seismic wave data for decades. Earthquake waves slow down when they pass through this region, and for years, no one could explain why.
The ringwoodite discovery finally gave them the answer. Water changes how rock behaves at the atomic level, and that shows up in how earthquakes travel through the deep Earth. In other words, this ocean has been leaving fingerprints in earthquake data all over the world. We just didn't know how to read them. This isn't just a cool fact for trivia night. It could rewrite entire chapters of Earth's story. First, the origin of our oceans. For decades, the leading theory was that water arrived on Earth from icy comets and asteroids billions of years ago. But if the mantle has held enormous amounts of water since Earth's formation, some of our surface oceans might have come from inside the planet, not from outer space. Second, this hidden water may influence volcanic activity, the movement of tectonic plates, and even how earthquakes behave, because water changes the melting point and flexibility of deep rock. Understanding this reservoir could help scientists explain not just how Earth formed, but why it became the one planet in our solar system covered in liquid water at all. So does this mean there's a giant underground sea waiting to be tapped? Not exactly. Researchers still don't know exactly how deep this water reservoir extends, how evenly it's distributed around the planet, or whether other regions of the mantle hold similar amounts. Some studies suggest water pockets could exist even deeper, near the core mantle boundary, nearly 2,900 kilometers down. If true, Earth's hidden water story might be far from finished. This is still one of the most active areas of research in modern geology, and new studies are being published every year. So the next time you stand at the edge of the sea and watch the waves roll in, remember this: the largest
ocean on this planet might not have a horizon. It might not have waves or tides or a single drop you could ever touch. It could be sitting in complete silence, locked inside solid rock, hundreds of kilometers beneath your feet, quietly shaping earthquakes, volcanoes, and the very existence of life on the surface above it.
Earth has been keeping this secret for over 4 billion years. And honestly, it's probably still keeping a few more. So here's the question I'll leave you with. If there's an ocean we didn't know about hiding inside our own planet, what else haven't we found yet? Let me know what you think down in the comments. And if this blew your mind, subscribe if you want more deep dives into the mysteries hiding right beneath our feet. I'll see you in the next one.